What's up guys, my name is Ritvik Rustagi and today I'm going to be teaching you everything you need to know about AP Physics C Mechanics Unit 1 Kinematics. So if you haven't already, please go to the description right now and get my free AP Physics C Mechanics book, and that book has everything you need to know to get a 5 and an A in your class. So what are you waiting for? Get it right now, and now let's begin immediately with Unit 1. So it begins with vectors and scalars. So a vector quantity has both magnitude and direction, and some examples are velocity and displacement, while a scalar quantity does not have a direction, only a magnitude, and examples are speed and distance. So the key difference is that scalar has no direction while vector does have a direction. So if you say that you travel, let's say 3 meters per second north, then that's a vector quantity because you just indicated the direction, while a scalar would just be I traveled 3 meters per second. So I know the magnitude of the rate at which you traveled at, but I don't know the direction. Now this is an example of distance versus displacement. So the displacement is simply the change in the two positions, while distance accounts for each intermediate step that you take. So average versus instantaneous rates. So average velocity is simply the displacement, right, divided by the time. On the other hand, instantaneous velocity is the velocity at a very specific point in time. And this same difference applies for average acceleration versus instantaneous acceleration, where average acceleration is the change in velocity divided by time, and then instantaneous acceleration is the acceleration at a very specific point in time. So acceleration is the rate at which velocity changes with respect to time. So it is delta V over t. These are some basics that you must know. It's important conventions. So basically, in general for a problem, use subscripts. For example, V of f, V of I, that means final velocity and initial velocity respectively. And this is very important because in a problem, you might have multiple different velocities that you are dealing with. So to reduce your chances of making an error, be very specific about what velocity is what specifically. So is that the final velocity or is that the initial velocity of when something starts? And then also remember that d or delta, which is this triangle sign of x, so like delta x or d, they both represent displacement. In general, use this delta x, it's just preferred. And if the acceleration is 0, then the displacement divided by time gives you the velocity. So now this brings us to the most important part of this unit, the kinematics equations. So there's 4 equations, and all 4 of these equations involve 5 variables: the initial velocity, final velocity, acceleration, time, and displacement. So please pause the video and memorize all these formulas. Now, what if acceleration isn't constant? So basically the 4 kinematics equations that I just showed you, they're true at constant acceleration. However, sometimes acceleration is not constant, and that's where you must use derivatives or integrals. So for example, dv over dt is acceleration. So this is useful if you want the acceleration at a very specific point in time. And then the derivative of the position with respect to time is velocity. And then if you integrate acceleration with respect to time, you get your change in velocity. And if you integrate velocity with respect to time, you get your change in position. Now, what is a 2D kinematics problem? So many people find a 2D kinematics problem tough, but trust me, it's not that bad. Because you use one key thing, and that key thing is that a 2D kinematics problem is 2 1D kinematics problems. So you're basically solving 2 problems at once. So please, whenever you have a 2D kinematics problem, work separately with motion in the x direction and motion in the y direction. And the reason is that the motion in the x direction is independent to the motion in the y direction. So it's useful to work separately with both directions. Now, what is one variable that is the same for motion in both the x directions and y directions? Well, time. Time is the same for both directions, so solving for time is useful. Because if you solve for time, you get information about motion in the x and y direction. Now, key facts about projectile motion. Now, at the top of the projectile motion, at the top of the arc, the vertical velocity is 0, while the horizontal velocity is constant. And then basically, the image, right, represents a ball in projectile motion. So assuming an object is thrown with an initial velocity of v0 at an angle theta, then the initial horizontal velocity is v0 cosine theta and the initial vertical velocity is v0 sine theta. And in general, in basically almost all 2D kinematics problems, there will be no acceleration in the x direction, which means that the horizontal velocity is constant. And then please write out all your variables in an orderly manner for all 2D kinematics problems. For example, I have written out the variables separately for x and y direction. So when I solve a problem, I know that, okay, this variable represents something for the x direction, while this one represents something for the y direction. Now let's look at an actual free response question from the actual AP exam. So please pause the video and try this official FRQ. Well, by now I hope you read this long problem. It's very long, but it's not that bad. In general, problems that look long to you, they aren't that hard. If you understand the meaning behind it and you apply some of the concepts you know, you can attack the problem. So basically, for part A, it's telling us that the sphere, right, it's released from the electromagnet after the timer begins. So what does this mean? That means the time that we record will be greater in this experiment, right? Because we're releasing that sphere after. So now, let's write this kinematics equation. Delta y equals initial velocity times time plus 1/2 at squared. So our delta y, which is the displacement, is just h, and this equals to 0 times t because we drop it at rest, so the initial velocity is 0, plus 1/2 at squared. So we can solve for a to get 2h over t squared, and a is the value of the acceleration. So this is the formula that we'll use to find our calculated acceleration values, the calculated values of g basically. And then, since a higher value of time is recorded, t is in the denominator. So that means we'll get a lower value of the acceleration, which is just g. So our calculated g value will be less than the actual value of g. Now it says that the electromagnet is released so that the timer begins when the sphere is released. And now the student will vary the distance h and then record the time it takes for that motion. And now it's asking us to indicate what quantity should be graphed so we can yield a straight line. So we already found that the acceleration is 2h over t squared. So if we graph h on the y-axis and t squared on the x-axis, note t squared. If you graph t, then that's not going to give you a useful thing because we know that h is proportional to t squared. So that means we should graph h and t squared. So now to fill out the table, all you do is you use one of the rows, you write t squared, and basically all the values of time given, you square all of them. And so that gives you this graph. So now using this graph, we can find our calculated value of g. And now that brings us to part D. In part D, we want to find the value of g using the slope of this equation. So we know that a equals to h over t squared, so let's use two data points. So let's use the data point of 0.451 squared, comma 1, and then 0.312 squared, comma 0.6. So if we can find the slope between these two data points, and then we can find that this is approximately 4.6276. So what we found is delta h over delta t squared. However, acceleration is 2h over t squared. And what we found is h over t squared. So the slope we found, we must multiply this by 2 to get 2h over t squared, which is the acceleration. And we get that the acceleration is around 9.255 meters per second squared. Now in part E, we're given the equation of the y position, right? The distance y fallen. And then we're given the constants for it, such as a, b, and c. And then using the equation, we want to write an expression for velocity and acceleration. So how would we do that? Well, we're given the position, and we know that velocity is the derivative of position with respect to time. So we simply differentiate the equation we're given for y. So we use the power rule to get that v equals to 2at plus b. And then a and b are constants. A is 5.75 and b is minus 0.524. So we plug both of those in to get that the velocity, an expression for it is 11.5t minus 0.524. And now to find the acceleration, we know that the acceleration is the derivative of velocity with respect to time. So now we differentiate our expression we got for velocity. And differentiating it gives us 11.5 meters per second squared for acceleration. Now let's look at another free response question from the actual AP exam. So please pause the video and try the problem. So by now I hope that you actually pause the video and try the problem. So basically in this problem, a projectile is launched from the top of a cliff above the ground. And then at the launch, the projectile is 35 meters above the base of the cliff. So basically it's launched at a cliff and then it's going to go in an arc, right? But it's going to go down the height of the cliff also. So basically in this problem, it says that the velocity is 50 meters per second initially with an angle of 37 degrees. And then the path of the projectile is also shown. So now we want to find the total time from launch until the projectile hits the ground at point C. Well, let's consider motion in the y direction, because in the y direction, we know that this projectile goes down minus 35 meters. It basically displaces downwards. On top of that, we know the initial velocity. It's basically 50 times sine of 37 degrees. And then we also know the acceleration, g. So since the initial velocity is 50 times sine of 37, we can use a calculator to find that that is around 30 meters per second. Now we also know that the acceleration in the y direction is g, and then delta y is minus 35, so we use the equation delta y equals initial velocity times time plus 1 half at squared. Now we plug in our variables to get minus 35 equals to 30 times t minus 1 half gt squared. And now let's use 10 for g, and then we plug in 10 for g, and we get 30t minus 5t squared on the right hand side. So now we can divide both sides by 5 and rearrange this to get t squared minus 6t minus 7. And if we factor this, we get t plus 1 times t minus 7. And then minus 1 can be a solution to this because time can be negative. So that means time is 7 seconds for this motion. Now part B says, calculate the horizontal distance that the projectile travels before it hits the ground. So we know that in projectile motion, horizontal velocity is constant. And what does that mean? So we can find the horizontal velocity by taking the component of the total velocity and multiply it to the time. So the horizontal velocity is simply 50 times cosine of 37, which is around 39.93. So I'm going to round that to 40 meters per second. And then the time is 7. So we use the equation delta x equals to the velocity times time. So that means 40 times 7 is 280 meters. Now thank you so much for watching this video. And please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.